I'm welcome you all. Happy that you joined. Sorry for not making the other webinar, but let's get started. So today, Josh and I will talk about how to integrate Spring data-neo-gs with Spring Boot. So all the new technologies that you can get your hands on, put them together into a really nice app, and we want to show you how quick it actually is and how easy it is to get going. This will be a more interactive session, so if you want to be part of today's Twitter graph, please tweet with something like Spring Data or @Spring Data and @Neo4j, and you can tweet about your attendance, you can tweet questions, you can tweet remarks, whatever. And if all goes well in the end, we can pull in your tweets into today's Twitter graph, and you can perhaps see yourself as part of this webinar. Okay. Today, I want to talk about how graph databases connect to NoSQL in general, how connected data is represented in NoSQL world, what Neo4j has to do in this whole area. I want to speak about Spring data-neo-gs, especially the newest version of Spring data-neo-gs. And then I will hand over to Josh, who will show us how easy it is to get started with Spring Boot and Spring data-neo-gs to write a small sample application that pulls data from Twitter and puts it into the graph. And at the end, we finish with the Q&A section. Okay, let's start with NoSQL. NoSQL is a really misused term in general. So because negating something to speak about a certain area of databases is not really a good idea. And that's why we personally treat this acronym as not only SQL. So that means if you look at NoSQL databases, we see all the well-known databases in there, key value stores like Redis, column-oriented databases like Cassandra, document stores like MongoDB or CouchDB, and graph databases as well, for instance, Neo4j. But we also see relational databases. And this all together is kind of the pool of tools, of today's tools that you can choose from if you want to solve your own application use cases with the specific data structure that your application uses. So whatever your application has to do, there are certain use cases, and you actually want to choose the best tool for the job. So you will choose the databases that are the best fit for both your data model and for your use cases. So, and that's what kind of NoSQL is all about, and also polyglot persistence in general is about. Okay, of course, if we say we have this whole tool set to choose from, then there must be a reason why some databases are better for one thing and some databases are better for another thing. And this all goes back to the volume versus complexity question. So we have these two dimensions. One is volume, which is data size. So you all know that the amount of data that's produced grows and grows faster and faster. And the other axis is complexity. That means more and more data is heterogeneous, it's loosely connected or optionally connected, but there's a rich set of connections and relationships between your different entities in your domain. And the different data stores solve these two challenges differently. So key value stores are really good at scaling. So you can scale them out over 1,000 machines or 10,000 machines or petabytes of data. But the data model is really simple. It's a key and a value. Both are opaque values. Your data store doesn't care about what's in there. Column family stores are a bit more structured, so they kind of have this wide column approach where you can have multiple columns of any kind of type and size for each of your entities. Document databases add more structure to the actual value. So you have a tree-structured document that you can index into and search into, but it still distributes the data with sharding across a large number of machines. And whenever you want to access a document by key, it's really fast. Whenever you want to access a document by an index search, it's more effort for the database. And whenever you want to have different projections, completely different projections, and for all of these three types of aggregated aggregate-oriented databases, you have to recompute other views onto your data. It's not kind of the main view, but other views of your data. And then, of course, you have relational databases, who suited us really well for many years, and they are kind of moderately complex and moderately sized data sets that you can easily handle with them. Graph databases, on the other hand, are kind of, in terms of size, similar, scalable to relational databases, but in terms of complexity, it's much easier for a graph database to handle a richly connected domain, to handle a lot of joins in a query, and to solve these use cases. But if you look at most of the use cases that are typical for today's enterprises and companies, then we can see that most of the use cases are actually solved by all of the databases, because 90% of those are kind of in this area of volume that all of the databases are good for. So of course, there are always a special use case, like for instance log management, that is not possible to do with all these data stores. But today we want to talk about graph databases, not NoSQL in general. So graph databases, this is, for instance, a graph of my LinkedIn profile. So that's one of the graph visualizations of a rich social network. And so there are lots of use cases actually for graph databases, because whenever you look at an object model as part of your domain of your application, then this object model is something like a graph. So you have entities, you have certain values in there that are connected to other entities via lots of relationships, via lots of connections. And the interesting part is then that it's much easier to map this object model to a graph database than to a relational database. And in general, it's not about just about the mapping of data into the graph, but also about use cases. So whenever you have use cases that are interesting, that means that go along a huge number of relationships, a huge number of joins, that want to find paths between A and B in a bigger graph, or that have to handle tree structures, or is definitely a good fit for the database. Speaking of use cases, I want to quickly take a look on how one of the most important use cases in the internet developed. So pre-1999, we had just basic indexing, like you do today with Racine. Just throw data at an index, put it in there, and retrieve it back. But that was really kind of just word frequency and things like that. But what a small company then did was to look at how are actually pages connected. So they kind of started to leverage the value of the relationships, the value of the connections between the pages, and started to rank pages by how many other pages refer to this page. And so the kind of first order of magnitude quality increase of the web search happened. And then we had that for a while, and we're pretty happy with that. But of course, there's lots of other information as well. So for every kind of search term that you have, there's lots of other information in Wikipedia, in Freebase, in other databases, in Yelp, and so on. And offer whatever they find in their index, but they also offer lots of additional information. So they augment the search results with additional information from other sources, and that's what they call the knowledge graph. So you see, from kind of basic indexing, atomic data, to starting to leverage the first connections, now we have really rich connected data in that search. So, and that's a typical example of how data management went from just solving kind of the individual use case, the atomic use case, looking just at one data item at a time, across managing connections, and now these days really leveraging the graph idea. If you look at some typical domains that graphs are really good for, so of course the obvious thing is social networks. I don't have to speak about that too much. It's about all the things that happen in the social network, all the activities that happen. You want to find people within your network, recommend people. You want to leverage kind of the intrinsic information it kind of spreads across the network over many hops and so on. So this is a really typical thing for graphs. Impact analysis, especially also network impact analysis, is also quite interesting. So what you do is you put, for instance, in a network management system, you put all your resources, all your devices, servers, routers, firewalls, and so on, switches into a big graph. And then when you have it in the graph database, then you can do things like impact analysis. What happens if this router dies? What happens if I have to repair this firewall? Do I have enough alternative routes to this server? What happens if this SAN is beyond capacity, and so on. But impact analysis is just much more than that. It's also really interesting when you, for instance, look at software and you want to see how software changes, how your software depends on other software, how this change in this piece of your application would affect other parts of the application. And so you have in many domains, also in manufacturing and so on, you have complex setups, complex networks, and you want to know what happens when something happens. And that's a really interesting use case as well. Something quite obvious is route finding, and we all know that kind of maps are really an old way of drawing graphs. So even in the old time, people drew the first graphs just by drawing maps, and everyone who knows used the navigation system knows that there are graph algorithms under the hood providing the shortest path information, for instance. Something that's not just for making fun of people, but actually really useful when it works, is recommendations. And recommendations is not just for retail, something like Amazon does, but also recommendations for things like job search or dating sites, or things like Spotify or iTunes or Netflix, right? Recommendations are kind of the core of many of these businesses because they make show people relevant content, and then with the relevant content, of course, people are more engaged with whatever they want to do. And the graph makes it really easy to write simple recommendation algorithms. Logistics is similar to route finding, but it's much more involved because there are many more domain details to that, like timetables and slots and availability and modes of transport and so on. And it's really interesting how even large logistic providers can use a graph database to actually route thousands of packages per second across a huge country. Right? So that's one of the domains where really high performance graph operations make a big difference as well. And this access control is a really interesting use case because what you usually do is you just take something similar, simple, like I have a group and a person, and I have permissions, and I can create from these simple ingredients an arbitrarily complex network. And whoever tried to solve an access control system problem with relation database knows that the kind of explosion of joins really kills performance. In a graph, you just turn the problem on its head, and you just say, okay, I want to find one path between this user and this resource where he has permission all the way along across all the legs of the path. And then when you find at least one path, then you can access the resource. So it's kind of changing the way you approach this use case that makes it possible. And something that Josh and I talked about just last week is workflow management, because there are really interesting graphs in workflows, right? Because each workflow with its dependencies, its participants, its documents, its kind of actions and so on forms just a graph. And there are even open source tools like Activity that people wrote connectors for Neo4j for. So that's kind of also an obvious thing. And the last thing I think is fraud analysis, which is interesting because you can just take the raw data of transactions, of bank transactions, of retail transactions, but if you put it into a different shape, if you put it into a structure that allows you to show how things are actually connected, and you see how money flows through the graph, or when people use multiple credit cards together and things like that. And you can easily find you spot the patterns because humans are really bad at hiding their trails. So because this kind of hiding something also becomes a pattern, and then it becomes obvious. So it's really easy to do things like that. So we see it's in every domain we can apply for the right use cases. We can apply graph databases the solution. And everyone has its own graph. There's the Office graph, there's the Crunchbase graph, the business graph of LinkedIn, there's the knowledge graph and Google, Facebook graph search, and so on. So everyone wants to use graphs to be smarter, and Neo4j allows you to just grab a graph database off the shelf, use it in your project, and be better than the next company besides you. And that's actually really cool. And it's really easy too, and you will see today that it's really easy. So, and actually everyone uses them. So now that we kind of took the kind of 10,000 foot view and looked at why are graphs useful and what you could do with them, now let's have a look at the details. So you know relational databases, I presume at least. Relational databases have tables. So for instance, here we have a user table and an account table. But what happens if you want to connect tables? You have to create a join table, at least if you have multiple cardinality. So you have end-to-end connections, foreign key connections between two tables. You need a join table in the middle, and that's in our case the user account table, because we have one account that belongs to multiple users, and one user, of course, can have multiple accounts. So it looks like this. The user is the red thing, the accounts are the blue boxes, and the join table is in the middle with the yellow ones. How does this look in a graph? We have the same kind of entities here shown as boxes, and those are called nodes and connected by relationships. And so we can represent the entities in our tables as nodes. So we have the red user entity and the blue account entities. And what was stored in the join table becomes a relationship between the two types of nodes. And here you also see what kind of graph databases do. They change something that's a compute query time operation in all the other databases to a structural operation. So graph databases pre-materialize relationships. So that means whenever a relational database has to go off and compute for many joins in the query, has to compute all the foreign key matches between your primary key and the foreign key relationships. Then the graph database can just say, oh, I have all these relationships already stored. I can just follow them to this other entity that's on the other end. And so that's every kind of complex join operation is a really cheap operation in a graph database. So which makes it really easy. If you look at the model that sits behind the property graph that Neo4j also implements, we have a few basic elements. So first on foremost, we have nodes, which are the entities of our domain. So we model everything that's usually an entity in an object model as a node. And we can also model attributes that are really important as nodes. So for instance, if you want matchmaking on a dating site, then you would, for instance, go across these interest nodes to find good matches for a person. The next thing that we just introduced with Neo4j 2.0 is labels. So we can have an arbitrary number of labels or tags on each node, which kind of groups nodes into categories or into sets. And you can also kind of see these labels as a kind of role. So you can have a person who is also a developer and who might also be a manager in a certain part of his job, but who's also for instance, a husband or a father or so, right? So all these different roles of this person have really different implications for the attributes and the relationships that we're interested in. And so these labels allow us to kind of represent all the different roles that a certain node can have in a graph and make it easy to work with them as well. And they also allow us to attach meta information onto the label. And then, of course, we have relationships. Relationship in a graph have also a name or type, and they are directed. But you can always choose to ignore the direction. So a direction is important when it has a semantic meaning in the domain, like in our domain today, Twitter. If I follow someone, it doesn't mean that the person follows me back, but it's a kind of semantic information in the direction of this follows relationship. And each node and also each relationship can have arbitrary amounts and types of properties. So you can have any kind of attribute on each node and each relationship, So depending on how much or how little you know about each of the nodes or relationships, you can just store this information there. And this allows you to also deal with heterogeneous data. So if you have just a tiny bit of information here or more information there, or if you have this kind of information for this node and a completely different kind of information on the other node. So you don't have to kind of make sure that the schema encompasses all these possibilities, but you just store on the node instance or relationship instance what kind of data you want to store. Relationships mostly contain attributes like that are qualitative. So, for instance, like ratings or weights or distances or time information. But you can, of course, store other information on relationships too. So that's the property graph model. So that's how Neo4j, for instance, looks in the inside. So really, we have data structures for nodes, you have data structures for labels, for relationships, for properties. It's really all stored on disk. And to be efficient in finding starting points for your graph traversal, for your graph navigation, we also use indexes to find the beginnings. So, okay, it's a different data model than we usually have, but actually I don't care how it looks in the inside, right? For me, it's a black box. How do what's the performance implication of that? So someone wanted to try that, so they took a primitive, simple social graph with a few friends per person, and they wanted to do this kind of bacon number LinkedIn thing, where you say, how many steps away am I from Josh, for instance, right? So they warmed up the database and had a query time in relation database of 2 seconds, because it was in total eight joins that they had to do. So one join for depth 1, depth 2, 3, and 4. And for each of these kind of distances, you have to have 1, 2, 3, 4 joins. And if you add them up, you get up to 8. And graph database was faster in path finding in the data. And even if you increase the number of elements in your graph, you still stay at 2 milliseconds, actually. I'm not sure why it's missing. So you should stay at the same time because what you do in a graph is you only look at local subsets of your data. So if you look at this kind of spatial structure of a graph, then you do queries inside your graph, then you can stay in a tiny subset. Graphs are also whiteboard friendly, so when I draw something on a whiteboard, I can actually draw my entities, my nodes, and relationships, and then when I put it into the graph database, I have the same structure in the graph database as well. Okay, that was a broken animation. Come on. So how do I query this graph database? Fortunately, we went ahead and created something like SQL. So actually, it's a query language called Cypher. And this query language allows you to specify patterns in the graph. So it's a pattern matching language. So you specify patterns that you're interested in. And with these patterns, you actually say, okay, I want to see this node, a starting point. Then I want to see, for instance, in this case, I want to see the tweets that he has posted. There's kind of 1 step apart, and 2 steps apart as kind of mentions of these tweets to other users, so which would be these nodes. And then I can just return them. So it's a really visual query language. It's really optimized for readability, and you should be quickly able to grasp it and write and read queries in this query language. Okay, one example is we can take fetch and say, okay, the information that I want to look at my friends. I have the information about a cuisine that is sushi in this case. And we can take these information pieces to kind of pinpoint nodes in the graph. And then I just start to look around these nodes and find the connected information. So I want to find these restaurants that are connected to these pieces of information. We can translate this natural language statement into a Cypher statement, which is representing exactly what I just said. So friend relationships, likes, location, and cuisine, being served a cuisine. And then we just at the next step, we just anchor certain of these patterns in the graph with a name, with New York and sushi, and then you can get all the restaurants there. And if you look at it, that from the outside, it finds a starting point and then traverses out from the starting points into the graph. Okay, Neo4j. Neo4j is of course a graph database, as you probably know. So that's a database that really enables you to leverage the connections that are hidden in your data. It's you can meta self-represent Neo4j as a graph as well, of course. I already spoke about most of these things. Something I didn't say so far is that Neo4j has actually asset transactions like relational databases, because we have this fine-grained data model that allows you to have these nodes and relationships, and you don't want to have partially applied updates. So you don't want to have 2 of 5 update operations happen, but you want to have all 5 or none happen. And you also want to make them visible only when all of the 5, when you commit your transaction. And this kind of scope that transactions offer help us to deal with this fine-grained data model. Neo4j is quite scalable, so both on a single machine as well as on a cluster. So it handles billions of nodes and relationships, and soon trillions, and can do many million traverses per second. And you can deploy Neo4j as a server or as part of JVM application. So if you look at Cypher again, so it's a declarative language like SQL. So you describe what you want, not how you want it. And it's based on pattern matching. So really, I want to specify graph patterns that I can easily reason about as a human. And the query engine goes off and finds these patterns for me in the graph. And it has also really cool support for collections. That was kind of the basic Neo4j quick glance. And now we can look at Spring Data and Spring Data Neo4j. So the Spring Data project, that you probably know, is an effort from Pivotal and Spring Source to provide Spring developers with an easy access to NoSQL databases. That means we have consistent APIs. It's not the same API, so it's not kind of having all the same API, just the same API for all the databases, but it's a consistent way of working. So because all the individual databases have really different drivers, different ways of working with them, and Spring Data makes it more consistent to work with these APIs. So that means consistent configuration. We have consistent repositories in Spring Data. Object mapping works similar. And while having kind of these same concepts in all places, you don't hide the power of each database. So you can always tie into the specific operations of the database, specific APIs, and leverage them as much as possible. We also share common infrastructure in Spring Data, and we have support for many different data stores. I think it's almost 10 now. And you find it there. And as you probably know, we have the Spring Data book, which I will say something about at the end as well. And Spring Data Neo4j was the first Spring Data project, actually, and it uses, like in GPA, annotations to define graph entities. We will see in Josh's live coding what it looks like. And we have the entity, the state of your entities, and is backed by the graph database, whereas an entity can be both represented as a node or as a relationship. And we also have 2 modes of the object graph mapping. Most people these days use the simple POJO mapping, and we still have an advanced SpecJ mapping, which is kind of read through and write through to the graph without having to copy data out and into the database. Of course, Spring Data Neo4j supports Spring Data repositories. There's a template, there's a consistent config. We have lifecycle support, so before, after, state events, and things like that. And Spring Data Neo4j also supports Neo4j server. There's a lot to say about Spring Data Neo4j, but I think it's easier to have a look. So today is also release day for the Spring Data project. So we see the GA versions of many Spring Data projects happening today. And Spring Data Neo4j will be released as 3.1 GA. So looking forward to that. Thanks to Oliver Gierke for all the work around that. And without further ado, I want to come to the actually core of today's webinar, the Spring Data Neo4j and Boot application, which is a combination of Spring Social to pull tweets from Twitter search, and it has a really simple domain. We have tweets, users, and tags as connected entities. We have repositories and services, and expose and export all these entities and repositories via Spring Data REST. So we can use it, for instance, from a JavaScript-rich front-end application like AngularJS application. And Josh will show us how to build this kind of application with Spring Boot. And we can connect it either to an embedded Neo4j database or a local Neo4j server. The project is online on GitHub, so you can also pull it down and play around with it yourself. If you look at the domain, it's really just a user posted a tweet. This tweet can be tagged with certain tags, and the tweet can mention other users, which then can also, of course, having had posted tweets, which can refer to the same kind of tags. Okay, Josh, please take over from here.
I am now the presenter, and I shall make myself the screen that is shared. Can you guys, what do you guys see? Michael?
I now see your desktop.
Which one? Is it STS?
No, I'm seeing the text editor.
Good. Okay. How do we change that? Stop desktop sharing. Move that over here.
Michael, we do have a couple questions from the audience while Josh is getting reset. Maybe you could look at those in the Q&A panel.
Yeah, I'm looking for it. Looking for it now.
The widget for it is cleverly hidden in the toolbar.
Yeah, I found it. I am not suggesting that Google, Bing, and the others are using Neo4j because large internet companies tend to write their own databases because they can. So whenever you have several thousand engineers available and limitless money, of course you write your own databases. You wouldn't use something off the shelf. But many other companies, including eBay and Walmart and Adobe and Cisco, use Neo4j, for instance. Let's see. There's another question. Does Neo4j support RDF? RDF is another graph database data model, which is based on triples to represent facts. And it's also heavily used in academia and semantic web. And RDF is really interesting because it took the approach of normalizing the data to the extreme. So you have for each attribute of your objects and each bit of information. And so you can represent an RDF model with a property, not as formant to do it directly in Neo4j. So what I usually suggest to people is to think about their domain, think about their use cases, and actually model a graph model or create a graph model that's the best fit for their domains, and then import the RDF data into it, because the property graph model is a more pragmatic graph database model. Okay, Josh, are you?
I think I've got this one. Wait a second, here we go. View, share my desktop. How we doing? What do you guys see?
Let you know in 1 second. It's coming up. Seeing it. There we go. I'm seeing STS. There you go.
Sweet nectar. All right, so let's get started. So, you answer all the questions? Okay, good.
Yep.
Let's get started. So Michael did an amazing job kind of introducing the big idea, the big picture. If you want to really, grok graphs, you have to appreciate them and you have to see the value of them. Writing the code is happily very, very, very simple. as we'll see in this example. And we chose a domain model, which, again, it almost bears no repeating. If you look at the diagram that Michael put up of, what Twitter's domain model looks like, it's nothing new to us, right? I don't think anybody needs to be taught how Twitter works. And that's the nice thing about graphs. They really are just sort of pictorial representations of models and domains that we already understand innately. It's just that the connections and the relationships there and sometimes aren't obvious. It's the same reason that mind maps work so nicely, is that they show you information you may already understand but don't see. You understand? It's implicit. So we're going to go ahead and code up that Twitter example. We're going to use Spring Boot because, we're lazy and we have a time constraint here, so we're going to get some stuff done here. And we're going to build up an application that'll read in the data from Twitter. So as Michael mentioned earlier, now's the time to tweet about Neo4j or Spring Central or any of these sort of things that are going to be picked up in our sweep. We'll see those in the results later. So the first things first, I'm inside of the Spring Tool Suite. To get started, I can go to File, New, Spring, Starter Project. And I'm going to go ahead and choose, Twitter as my base here with one T because I learned how to spell. Twitter, sure. And Twitter, okay. I'm going to go ahead and choose, we want REST repository support, we want web support. Other than that, I'm not sure if we need much else. Looking at this, yeah, that should be enough. We need the Spring Data REST support. We need the web support, and that's it. And then the rest we'll just add explicitly as we define our project. So what this does is it's going to start.spring.io. It's going to create a new project. Basically, that dialog is just a front for start.spring.io. Once you have the project in your IDE, you can open up the Maven POM and behold your work, right? So the checkboxes correspond here to dependencies in your Maven POM. And I'm going to go ahead and do a few things to bring this project up to snuff. I want 1.8, thank you, because I can't even imagine going back to 1.7 now. And then I'm going to bring in Spring Data Neo4j. Unfortunately, even though we're going to have the release later today, it's not GA just yet. So we'll use a milestone, that's okay. We'll use Hibernate Validator because we'll know we need that as well. So I'll replace this. This is useful for annotating your domain model with validation. And then we'll import the Spring Social Twitter module, right? So again, we're just bringing in a few libraries here. And then with that in place, Maven dependencies, Maven, update project. Give it a second. So do we have Spring Social? Looks like it. Do we have Hibernate Validator? Looks like it. Do we have Spring Data REST? Good. And we have Spring Data Neo4j. Do we? Yes, we do. We have Neo4j iterates, so that implies that that's all there. So with that out of the way, we can actually start writing our code. Michael talked at length about nodes and their relationships to each other and their properties and sometimes their labels. We're going to go ahead and express our domain here. Okay? We're going to express it using the object graph mapping tools that come with Spring Data Neo4j. These annotations work very much like you would expect simple JPA annotations to work. They're not JPA annotations, thankfully, but they are familiar, I think. So if you look at our domain, first things first, we're going to have a user object, somebody that posts a tweet, okay? The user object is going to be a node entity, of course. So there we go. And then it's going to have every object that you create in Neo4j has an ID. I wouldn't use this as like a primary key. It's an internal representation of the ID, but it is in some cases ephemeral. So this is not to be kept forever. But it does give the object a way of sort of discriminating itself relative to other objects that are floating around. We want a primary key and a few properties. So by default, every field in your object, every property becomes a property on a node. So basically, what you're seeing here is an object that's going to write through to a node instance, basically, unbeknownst to you. So all you're doing is just helping that along by annotating certain fields accordingly. So here I'm going to say I want a date for the created date, etc. These are all the properties, right? This is my node. Every node for a user is going to have a username. It's going to have a name, you know, my actual given name versus my Twitter handle. It's going to have the user ID, which is going to be derived from the Twitter API. And of course, for good measure, it'll have some copy constructors. So we'll paste those in here. Okay. Now you see here, I'm depending on the Twitter profile type that comes in from Spring Social Twitter. It's just a copy constructor, so I can take a given Twitter profile and then create a new node out of it. And I can use this node however I want, right? But this is just one type of node. It has no relationships yet. I mean, you know, it's kind of pointless. So we need actual relationships here. So we're going to go ahead and set up the next thing. Users post tweets, right? The Spring Social Twitter API already has a tweet object, and it can make coding a little cumbersome. So we're going to create a message object and then alias it to point to tweet, right? So we're going to use this type alias annotation here. So in the graph, it'll be stored as tweet nodes, but behind the scenes, we're just creating objects of type message. Much cleaner for our domain since we're going to be dealing with two different types of tweet objects. And then here's where we start to actually have some of the rich relationships that we want, right? So here we can see that I have a user that posts a given message or given tweet. All the tags that could be tagged in a given tweet, right? So I might, you know, tag, hashtag, right? So like # Neo4j, right? That would be represented here as a tweet. And you notice that we don't have a tag object yet, so that doesn't make any sense. But you notice that each one of these is a annotation that tells you the kind of relationship. You can also specify the direction, right? So if you want to specify which direction a relationship goes, it's fine. The relationship there is useful. Actually, that's what's happening up here. We're posting the direction here, right? But by default, oops, wrong one. Go with that one, sure. No. By default, grab this guy here, paste, happy, good. By default, you get the equivalent of it. You get incoming, right? So that's just, this is redundant in this case, but it's what you would get otherwise. Waiting for the source code. Defines, there you go. So you can see it, if I want a relationship that goes out versus in, this is the enum to use. The utility of this is what Michael described earlier when he pointed to the idea of, you following the user, but the user doesn't follow you back. If you want to express that, you can express it in terms of direction, right? So that's a very, very useful discrimination here. It's a very useful way of breaking apart the model in terms of the relationships, not just the properties on each node. Okay, so then the final thing we need, of course, are our copy constructors and our constructors in general. And then we need some accessors, right? So I'm going to paste that. You can see here we've got mentions as well. So all the other users that mention this tweet are going to be represented here in the graph. And of course, if this is a retweet or something, we'll know about that as well. The @fetch annotation tells Spring Data Neo4j that we want to eagerly load the relationship. So otherwise you get lazy loading, which is perfectly fine for any given use case, but we want our data eager here. We should have a toString, so we'll go ahead and do this. Generate a toString. Sure. And we need the getters. Okay. And then we need the actual getters for the user. Okay. And then finally, we need the actual tags themselves, which is what we saw earlier. Mentioned whenever we use a message. So here's a tag entity. So again, this is, again, very, very simple object, right? You've got an ID, you've got a tag field itself, the string, a very basic toString connected to the messages and connected to the users, right? So this is the example model I saw depicted in that graph diagram earlier, just now represented as 3 different types of entities. I'm lazy, and I'm, just trying to get a demo done here. Obviously, there's no restrictions about which package you can put this in. I'm just keeping it in one code page so we can kind of follow along and watch what's happening at home, but feel no need to do that yourself, okay? This is, of course, a Spring Data project, so you can benefit from repositories. The repositories, I think, are one of the biggest wins here. Cypher is already a very, very high level, so you might argue that there's not a lot to be gained by having a repository handle the extra bit of indirection, but less strings in your code is always a good thing, right? So this, if for no other reason than to avoid that, you get a lot of that extra benefit from common case stuff, right? So what I've got here is a repository that manages tweets, that extends the graph repository that comes with Spring Data Graph, and I've got methods that will provide results based on convention. So find by tweet ID is going to select all from it's going to basically find all the messages that have a tweet ID that is equal to the value that's passed in here, right? It'll write that as a Cypher query in the background for you, so you don't have to worry about figuring out the query for that or the syntax. And if you want to change it, you just change the convention. Of course, you're more than free to express more complex ideas as actual queries on Finder methods, right? So here we have a ingenious little Cypher query that Michael devised in about, 2 minutes that finds the trending tweets. So basically we're saying find every node that has a type user where there's a relationship of type posted to a tweet that also has a relationship of type tagged with a tag, and then return the tag as the tag, and then the count. So this is kind of like, if you look at this, we don't actually have a group by like you would expect in SQL. This just happens automatically whenever you have an aggregate call in the return. It'll take the other ones as the group by value, basically. So all the other columns combined are what contribute to the group by value for the count here, or for the aggregate. And so in this way, it's very, very simple, right? You're saying return every tag, and then the count of every tag, order by the highest number going down, right? And then limit to 10. So we're getting the top 10 most trending tags in our graph at any given time. Not bad. And you can only imagine, that would be fairly gnarly query to write otherwise. And then we're going to go ahead and create a user repository, something for actually working with our user database. So again, this is a Spring Data Graph repository. So I can trust that when Spring Boot and Spring itself starts up, that I'll have a type in my bean context that implements this interface and that provides the methods that we're defining here. So these are all going to be provided by convention. I can just inject instances of type user repository or tweet repository and not worry that they're going to work, right? So here, same kind of thing. I want to find a user. I want to find a user by their name, right? I can specify that here. I can also annotate them with parameters, for example, if I want to change the way that's exported to the web. And again, I've got a nice convenient query here for finding users that I've interacted with as somebody on Twitter, for example, in discussions and so on, where those users follow me, but I don't follow them, right? So it's a good way of finding people that I might potentially follow. So this is, again, a fairly complicated query, but it just falls together very, very nicely with the graph language here. So we're saying match every user given the user name, and this user name is going to come from this parameter, right? So this is going to be bound into this is the named parameter, if you will. It's going to be bound to this parameter here. Find every user with that user name, and then traverse the posted relationship to find the tweet, any tweet that has a mentions relationship with any other user, or with this user, where I am not the same as the user that's being mentioned, in which case return that user. So that, again, that finds everybody that isn't me, that I've interacted with, that I might want to follow. And with that out of the way, we can actually build our little importer here. And this is actually, you know, when you think about it, this is one of the easiest parts, right? We actually have to just put together a little program to import all the data from Spring Social. We need to set up a few things. We need to, of course, set up our connection to our graph database. As Michael mentioned earlier, there are two different types of ways to work with the graph database. You can work with it embedded in memory in your local virtual machine, or you can point to a REST-powered variant, right? So that's what I'm doing here. I've used Homebrew, and I've run the installation on my machine, and I can just go to the command line and say, Neo4j start, right? The other thing I'm going to need is, of course, a Twitter template. So I've defined here a Twitter template that's going to, it's powered by Spring Social, and all that's going to do is it's going to give me access to Twitter, basically, so I can do searches and find the results. To make sure that that works well enough, I'm going to add some properties to my property file, including the query. So you can see here I've got the query is Neo4j, where it has graph or database, or graph or databases, or GraphDB, or Graph Connect, or Neo4j, or Neo4j-DB, or Neo4j-DE, or France, or Spring Source, or Spring Data, or Pivotal, or me, or Michael, or Spring Central, etc. So these are all the queries. This is the query we're going to run on Twitter. We're going to connect to this host here. I'm going to use this Twitter bearer token. Don't pass that around. Thank you. And we'll use that to connect. So that'll give us permission to talk to that machine. And then from there, we can actually just start sort of building our tool, right? Or building our importer. We have Java 8. I'm using Java 8 here, so it actually falls together very, very nicely. Let's build a class here. At service class importer. And then this is just going to be some component that gets run on a periodically that imports the data coming in from the results from that Twitter search, right? So at service, okay, as scheduled. Initial delay is 10 times 10,000 times 1,000, and then it's going to be fixed rate. We're going to say we'll want this to run 10 seconds after we start, and then for every 10 seconds thereafter, right? So it's going to be like this. Import to search results. And I'm going to go ahead and give myself a little bit of breathing room here. And we're going to go ahead and use the search operations that we're going to get from dependency injection, right? So we need a few different things here for this to work. We'll import those here. So what I've done is I've defined an object type search operations. This is the object from Spring Social Twitter. And I've defined a few places where I need some dependency injection here. I'm saying to Spring, give me the Twitter template, and I can use that to dereference my search operations. I'm asking it to give me a reference to the user repository, to the tag repository, and to the tweet repository. This, why is that guy unhappy? Oh, of course. We forgot to paste in the tag repository here. And you know why? Because it's so small. This is why. There. You'd hardly even miss it. One thing you should also note, we have here the Spring Data REST annotations. So these are going to be used to export all the data from the graph here. So now we have all this information. It's a clean way of interfacing with the data, and it's being exported as a REST resource for us, all transparent to us, right? With all that in place, I can now go ahead and build the actual few lines that we need. So I need all I'm doing here is I'm setting up the operations I need. I need a search operations, I need a user repository, tweet repository, tag repository, and the environment. I'm just doing a demo here. Of course, you shouldn't do this stuff, not even at home. Use constructor injection and so on. It's good, clean fun, and you'll feel better in the morning. So there we go. Paste that. Get rid of this, and undo that. Good. So what we have here is a Java 8 call. It's Java code calling search operations. I'm saying call this object. Add mention. Oh, I have to add domain objects here. Domain methods. Here's my tweet message, my tweet object. So I can just shortcuts, right? Again, these don't actually do any hard work. They're just convenience ways of enriching the data, enriching the model as we go, right? So I'm creating a message here. Every message has the ability to add a tag. So I'll go back down there, and then go back to our application itself. And then we have the ability to add a mention to every message. So I'll go ahead and add that as well. Voila. Okay. Paste. There we go. So what we have now is search operations.search. Ooh, that could be a little bit uglier. I'm not sure how though. Good. So okay, I'm saying for every result that comes back from the search, given the source tweet, right? This is the type that we want to avoid conflicting with, which is why we renamed ours locally to be message. For everyone that comes back, create a new user, right? So we're going to say, get the user from the source message. We're going to save that into the graph using the user repository. Then we're going to create a new message, representing the tweet, right? And it'll have the ID, it'll have the username, it'll have the text of the message itself. And then we're going to say, okay, from the source, find all the mentions, and then for each mention, iterate through it using Java 8, queries. I'm just going to do a for each basically. Iterate through every mention, and then add the mentions using the user repository here, right? So these are all the users that were mentioned in this tweet. So these are other nodes. And remember, this is going to act like an upsert, right? So if I've already got this data in the database, this addition is going to describe nodes that no doubt will exist later on. And because we have those indexes in place, let's see here, go down here. Right, because we have at index and so on in place, these can be used to determine whether this object should be upserted or not, whether it should be unique or not. So that's just happening for us very conveniently, and it's very, very quick. So we're saying, okay, add each mention, and then same thing down here. We're going to say for every hashtag, iterate through the collection, add the tag, and then save the tag to the database, right? So I'm using just Java 8 lambdas for each tag, Twitter add a tag, and then save the tag as we go. And then finally, we save the actual tweet itself. And then here we have a celebratory sort of brush on the shoulders, congratulatory, you ran it, it's running. Bit of output, right? So that should be the sum total of that. I think the only thing we're missing at this point is the sparse little bit of configuration to actually turn on Spring's Neo4j support and scheduling support. So I'm going to go ahead and turn on all of that here just by adding these at the top here. So what we have here is @enable Neo4j repositories, @enable scheduling to turn on scheduling. This is going to turn on Spring Data REST, right, which is very convenient. This is going to turn on declarative transaction management because, again, just like with a SQL database or JMS or AMQP, there's a notion of transactions with Neo4j. So you don't have to give up on that just to have this really amazing graph model. Okay, let's see now. That's running. Does that look good to you, Michael? I'm going to go ahead and assume that it does, but we shouldn't forget one more thing. We have to extend Neo4j configuration. That's the last bit. So this is going to be a class that extends Neo4j configuration. This is a base class that you can use as a convenience, right? It just sets up everything. We'll have the constructor here. And then with that, we should be able to run. So let's do this. Run this application. As this is going along, it should pick up data, hopefully. Hold on. Okay, it's up. Wait for it. Oops. Yes, okay, no argument constructor. Fair enough. So, tag repository. select all, okay. And then, okay, we've already got a message here. What about this guy down here? Tag, good. And then user, public user. Okay, and then because we're sort of short on time and I want to see the results of all this cool stuff as we're going, I'm going to also print out, I'll start up the application again, but this time I'll print out the results of some of these really cool queries that we've got in our repositories. I'll do that by way of a command line runner object, which is a bean that will get, run when the application starts up. It's a callback that Spring Boot provides, and basically it's just a chance for me to run the code when the application has started up with the public static void main arguments, right, passed into the callback here. So, Control C that, run. What I'm going to do is I'm going to print out the trending tags here. I'm going to say Twitter repository trending tags class. Okay.
Josh, I think the compiler is telling you that's an illegal operation. I'm hearing sirens.
Yeah, right. Sorry, that's the cannot access members of class demo users with modifiers public. Fine. Wow. There's a interesting. Let's just try this the hard way because I want to get this done with. Message. I always forget which types you can promote to a direct, to be public, and which can just be packaged private. Okay. Paste that in there. So all I'm doing is I'm pasting stuff into public classes instead of just having them in the same code page. It's my own laziness come back to haunt me. Don't know why. User. Okay. And then finally we need the tag. Okay, voila. Tag. Okay. With any luck. Run again, this time with fingers crossed. Hopefully. No idea. All right, now we're cooking. So I ran the query. As you can see, the code starts up and at the top here, and it's gonna, at first, the first thing it does is it says, okay, print out all the trending tags. So again, I've already run this before, and there's actual Spring Social code printing out anything and everything that's found on Twitter that happens to match our query in some way. But when you see the output here, I'm going to go ahead and pause this for a sec. That's okay. Good. You go to the top here, you see the amazing, impressive ASCII artwork. Scroll down a little bit. You see the top trending tags in the data. So we've run this data set before, right? So we've run this analysis before. These are the trending tags according to that query for this data. Here are a few users that we should be following and that I should be following and that Neo4j should be following. I forgot to put the two strings, so we don't actually have that in there. Very happily, we can also look at this data inside of Cypher, inside of the Neo4j console. So again, very simple. Go to the command line, Neo4j. Yeah, whatever, it's already running. Localhost 7474. And we're now into this very, very convenient little console. And what I'm going to say is run. So that gives me the same, that's the same query, right? That's the same results that we asked for before. Not quite as fun to look at as this one, I think. Let's see. Spring Central. So you can see we've got these nodes that we've interacted with that we might do better in following from the Spring Central's Twitter account. So that information comes back very quickly, very nicely. Even better, if you just want to see all of it, you can just say match user, return you, and that'll give you everything, right? So if there's any relationships to be seen, you can actually just start splinking around. Whenever there's a graph or some sort of connection, you can see that information in here. Do we have any results with connections? Match user posted tweet. Oops. See how easy that is to manipulate? There you go. Tweet. There we are. There's the web we weave. That's just the users and their tweets, right? So we can see that you can see all these connections. You can actually kind of visually navigate them and see where they lead to, and see where the clusters are. I mean, visually you can just see the data. That's one of the beautiful things here. Of course, you could also add information about tags and connections and so on. But I think you have the idea, right? We have this application together. It actually works with. It actually runs all the stuff we've just looked at. It's actually working very, very quickly. Didn't take a lot of smarts. We were able to do certain things like recommendation. This is like a recommendation engine, if you will. We're able to do that very, very quickly in very, very small amount of code. As a bonus, we used Spring Boot. So, of course, now I can go to localhost 8080, and I can go to this and get bupkis. Oh, because I closed this. But if I'm running this, job application, okay, I can actually see all the RESTful data coming back here as well, right? So here's all the information that we've got in the database, now easily accessible from a graph, which is very, very cool. Okay, Michael, what do you think?
Impressive, Josh. You were really super quick in getting this demo together. I am really...
That's hard to have run a little long.
Well, it ran. Oh, that's no problem. So I think it shows clearly the power of just specifying a handful of domain entities, pulling data from somewhere, populating the entities, put it in a graph database, and then be able to find implicit connections, find new interesting insights in your data, and be able to leverage that data much better. That's
right.
Really impressive.
Yeah, well, thanks.
Cool.
This is your code, right?
Yeah, but you put it all in. I mean, it's really impressive that you got going so quickly. I mean, it's really, really cool.
I'm a fan too. The Spring stuff's gonna take off. You just watch.
Really cool. So to finish off, I think we answered almost all the questions. There was one question left that said, is there a JAX-B integration to generate these classes? I'm not aware of one, but it shouldn't be too hard to generate the data from any kind of model, so from XML or like workflow descriptions or JSON data or whatever. You could just inspect the data and then generate these classes from that. But actually, it's not so much code that you really have to generate them.
Right. This is simple enough that even I could do it. This is actually, when you think about the problem of modeling your objects, when we think about, like, you guys remember Xstocklet and all those horrible things used to generate your entities in terms of a SQL database, and it was because it was just so hard to teach your object model about these relationships. In this case, you've already got this, your objects want to be bidirectional. They want to have relationships. They want to have that semantic meaning. So this is natural to model. You don't have to think too much about whether it's bidirectional or not. As long as you've got it pointed to another object and you map it correctly, it'll work. You shouldn't need another model to generate the code, hopefully.
Yeah. Could I quickly, for finishing up, get my screen?
Yep, sure.
Online?
One last question coming in. One last question coming in from Raymond Lee, and he was curious if. Oh, hold on. Sorry, my question bar just went away. 1 second. Raymond asks, can a graph database be used in place of an OLAP queue?
Yeah, that's a really interesting question because what you can actually do is in a graph, as connections and relationships are so cheap, you can add arbitrary additional access structures. So you can represent your Euler cube by just adding tree structures into your graph that allow you to access your data across a number of different dimensions. And then if you want to, you can also aggregate data on top within this tree, so you have a really fast way of accessing aggregated data like that. So a colleague of mine, Kenny Bastani, actually did a series of blog posts. So if you look for analytics and Neo4j, then you find a series of blog posts that show you how to do that. Really cool.
Kenny's really good at this stuff.
Yeah. So we also have the Spring Data book that the Spring Data project lead wrote with O'Reilly. And I think we have a few copies available. So Peter will pick some people at random from those that attended at the webinar. And,
yeah, we'll pick 50 attendees from the registration list, and you will be sent a copy of the Spring Data ebook. Basically, keep an eye out for in your email in the next week or so from an email from O'Reilly. If you win, we'll simply send your registration information that you gave us to O'Reilly, and they will create an O'Reilly account for you and deposit the ebook into that account. So keep an eye on your email from O'Reilly in the next week or two here. We'll be sending the data to them later today. May take them a few days to fulfill it, but there will be at least 50 winners from this registration list. So you've got a pretty good shot, actually, at winning a book. And thanks again, Michael, for your contributions to that book, as I see your name right there on the author list.
It's there as well. That's true. Yes, and then a quick heads up. So if you're on the in the US or on the West Coast, we're running a graph conference in San Francisco in October. And right now, passes are really cheap, so grab one if you want to.
I'll be there.
And if you want to, yeah, we will all be there, right? So, and if you want to learn more, just visit neo4j.com or neo4j.org. There are also trainings available for Neo4j inside for online and offline training courses. And of course, the Spring Data projects are all to be found under Spring.io projects. And there are many more interesting things to be found there. And if you have any questions, then don't hesitate to ask Josh or me, either on Twitter or via email.
We won't put those in the database. We might. Never mind.
Yeah. Okay. Thanks a lot for your time. We really appreciate it. And it was a lot of fun working on this webinar with Josh. Thank you, Josh.
Thank you. It was fun working with you, Michael.
I really enjoyed it.
Likewise.
Yeah. Cool.
It's
all right, guys. Real quick. Nice. Real quick, everyone, just want to mention that this webinar is being recorded, and you can access the recording. We will post a replay, so you can share it with your colleagues that might have wanted to attend this, but did not. So I just put the URL in the Q&A window as a response to Raymond Lee's last question there. And so the replay will get published there. If you'd like to get notified about the replay, you can simply just subscribe to the Atom feed. That is at Spring.io blog. And I'll just pop that URL here in the window as well. So you can subscribe to the Atom feed there, and then you'll also get all the great blog content from our engineers as well. Spring 1.2 GX replay sessions and all kinds of great stuff. If for some reason you just want notification of new videos, you can just go to Spring.io video and subscribe to the YouTube channel. But I highly recommend you subscribe to the Atom feed instead, as you'll also get all that blog content I mentioned. Great. Okay. Let's see. We also have a number of good webinars coming up. So if you're interested in coming back to join us for another session, we've got some cool stuff coming up. Let's see. Our next one is going to be on June 3rd. Ramnivas Ladat is going to be talking about Spring Cloud, which is an interesting way to create a GA of a new project. Interesting way to write PaaS portable applications, as PaaS offers, every PaaS vendor offers its own proprietary services that you can pass through the PaaS. Spring Cloud is a way to write against individual PaaS providers in a platform neutral way. Write your applications, in a PaaS platform neutral way. On June 10th, Michael Minella is going to be talking about Spring Batch 3.0 release and the new JSR 352 support. And on June 17th, he's been working on that release for a while. And on June 17th, Glenn Renfro is going to talk about Spring integration and Spring Boot. Again, you'll see all these webinars posted on the website. I just wanted to let you know they're coming. And again, if you are looking to get HTTP downloads of bits for things like Spring Data, Neo4j, for example, just realize that we have not yet enabled direct HTTP downloads on the website. We generally, the experience with Maven is just much, much, much better. So we really try to encourage you to use Maven or Gradle to do that. So if you do need, however, HTTP downloads for some reason, you can get them from our Artifactory server, which is located at repo.spring.io. I'm going to put the URL for that there in the chat window. And if you have never worked with our Artifactory repository before, there's a quick FAQ that you can visit here on GitHub that will introduce you to the repository. So if for some reason you absolutely need HTTP downloads and you can't use Maven or Gradle, you can use our Spring repo for that purpose. So with that, I think we're all set. Josh, Michael, nice job. Anything you want to say before we close it up for the day?
Yeah. So I just want to encourage you to try it out. So just grab Spring Boot, grab Spring Data Neo4j, grab a data source that you like or some data that you have around, and then try it out. I mean, it's really, really easy. Wikipedia, whatever, right? I mean, there's YouTube, there's Stack Overflow, Meetup.com. There's so many APIs that you can pull data from. And then, give us feedback. We love to have feedback. So as every open source project needs the feedback of its users, we love your feedback. And if you have any questions, don't hesitate to ask us.
+1.
And thanks again to the Pivotal team for making this possible. To Amy, Peter, and Josh.
No worries, Michael. Have a great day, everyone, and thanks for your time and your attention and your questions. We'll see you on another webinar very soon. Bye-bye.
Thanks. Bye.